Okay, we're live. London Bitcoin Dev 0.3. We have John Light, who's co-founder of Bitseed, with us, and I'll hand over to John.
Yeah, thanks a lot, Michael. I'm really excited to join you all. So as Michael mentioned, my name is John Light. I'm the co-founder of Bitseed. I'm going to go ahead and get started with the slides because I have a nice little presentation that I've made for you all today. Just let me know if you can see the presentation on full screen mode. Does it look good?
Yeah, we're good.
Excellent. Right, so my presentation today is going to be about Bitcoin full nodes, everything you wanted to know and more. There should perhaps be an asterisk because I'm not going to say literally everything, but if anyone in the audience has any questions that want to go like really deep down the rabbit hole, then we'll see just how far down we can go. As I mentioned, John Light, co-founder of Bitseed. Our website is bitseed.org if you want to check it out later. And I'll talk a little bit about what we do there at the end of the presentation. And that's my Twitter handle if y'all are on Twitter and feel like following. So kicking things right off, what is a Bitcoin full node? A Bitcoin full node is a computer that runs a fully verifying implementation of the Bitcoin protocol. This means that these full nodes verify that every block created by miners are actually following the rules of the Bitcoin protocol. These are some of the implementations, the different implementations that exist of the Bitcoin protocol. These all basically implement the same rules so that they can all stay in consensus on what is the current valid version of the blockchain. There's Bitcoin, which is a JavaScript implementation, Bitcoin J, which is a Java implementation, libbitcoin, which is a C++ implementation, BTCD, which is a Go implementation. I don't think that's actually their logo. That's just the Gopher. And Bitcoin Core, of course, which is the kind of like most popular implementation of the Bitcoin protocol. And Parity also has a Bitcoin implementation in Rust. And there are several other full node like clients that you can download. These are just kind of, I think, the most popular ones by language. These are kind of like what Bitcoin full nodes look like when they're running inside. Usually these are the kinds of nodes that people would run at home. You could also, of course, just run a Bitcoin full node either like on your laptop or desktop computer or run one on a server in the cloud. But for the people that decide to run like dedicated hardware nodes, these are usually what they look like. You've got them like running on a Raspberry Pi, or in the case of Bitseed, either another different kind of small ARM board called a PC-Duino Nano 3 or a mini PC. And these usually have enough computing power and hard drive space to run a full node. That's actually an old model of Bitseed in this picture. I just pulled it off the internet. Yeah, we'll take a look at what Bitseed looks like today later. So what are some of the rules that full nodes enforce? These are just some of the rules. A kind of full list of rules is, you can find that on that link in the source at the bottom of this slide. That's on the Bitcoin Wiki protocol rules page. But for example, some of the rules that full nodes enforce are like, they make sure that every transaction in a block is valid, meaning that like the sender actually has the money. They're not just kind of printing money out of thin air. The money has not been spent before. So basically preventing double spending. And the signature actually matches the sender's public key. so other people can't spend your money kind of on your behalf. And another example of a rule would be like every block has the required amount of work. This basically keeps the miners honest, so that the miners aren't able to, produce kind of arbitrary unlimited amounts of blocks without doing the appropriate amount of work. And like every block is equal to or smaller than the max block weight limit or the max block size, which is currently 1 million virtual bytes. Bitcoin used to measure block size in terms of bytes, and now that it's measured in weight units or virtual bytes. So what are the different types of full nodes? There's actually multiple different types of full nodes. One of those is like a pruned selfish full node. There are archival selfish full nodes. There are pruned listening full nodes, archival listening full nodes, and then perhaps the most important of all of the full nodes, the economic full nodes. And we'll dive into each of these in detail here. So a pruned selfish full node basically prunes raw block and undo data by deleting it from disk. Prune nodes really only keep the data that they are interested in and maybe a little bit extra, just to be somewhat useful to the rest of the network. And when I say that a full node is selfish, I mean that this is a Bitcoin node that does not upload data back to the network. So it's only downloading data. In torrenting lingo, this would be like a leecher, where it's only downloading data. It's not uploading data back to the network. So these nodes are only downloading and validating blocks locally. And finally, users of pruned selfish full nodes get the benefit of using their own full node because they are fully verifying all of the blocks, new blocks that are created by miners. But they're saving hard drive space by deleting data that they're not interested in. So they like validate the block, throw away what they don't need, and only keep what they need on disk. Then there are archival selfish full nodes. And like I said, a selfish node is one that does not upload data back to the network. But an archival full node specifically stores a complete copy of the Bitcoin blockchain data on disk. So it doesn't delete anything. It actually keeps the entire history of the Bitcoin blockchain on its hard drive. And with this complete copy, it can make queries against the blockchain to find information pertaining to particular transactions or addresses. And if it wants to do more advanced queries, then the full node will have to build a full transaction index from all of that data that it has stored on disk. So, the blockchain is like a raw source of data. And then from a transaction index, you can build things like block explorers and other kinds of complex querying databases. So then there are also pruned listening full nodes. So as I mentioned, pruned nodes only keep some of the blockchain data on disk. But if it's a listening full node, then that means that the Bitcoin node is actually uploading or relaying Bitcoin block and transaction data to other peers on the network. So whenever a new peer comes online and it's like, hey, give me the latest blockchain data, then listening nodes will hear that request and respond by sending the peer some blockchain data, usually blockchain data that the peer doesn't already have. So listening nodes can connect to peers over the ClearNet, basically the regular HTTP IPv4 network, over Tor or both, which would be like a hybrid mode that bridges the ClearNet and the Tor network. Hybrid nodes are important because they provide a critical link that passes blockchain data between the ClearNet and the Tor network. Otherwise, they would be two separate networks kind of partitioned from each other. And that would, of course, cause a split, and that's no good. So listening nodes do have the ability to limit the amount of data that they upload per day in order to save bandwidth. If you just like left it uncapped, you could end up uploading, many gigabytes worth of data per day. And a lot of folks who run the full nodes from their residential internet connection, their ISP will impose bandwidth caps both on downloads and uploads. And so if you don't limit the amount of data that you're uploading, you can actually hit that limit pretty quickly. It's not like super common, but it can happen, especially if there are a bunch of new peers joining and they're like downloading the entire blockchain from you multiple times throughout the course of the month. And finally, of course, because Pruned nodes are not storing all of the data, all of the blockchain data, they are unable to upload copies of archival block data that they do not actually have. And so they are only able to share the data with new peers that they actually have on disk. And then there are archival listening nodes. So because these are archive nodes, they can upload complete copies of any blockchain data to other peers on the network. They have the full history of the blockchain stored, so they can upload that full history if a peer requests it. These nodes are useful, indeed necessary, for bootstrapping new full node peers or helping SPV wallets discover the balance of their addresses. And archival listening full nodes are really important for preserving the integrity and the history of the full Bitcoin blockchain, because they are storing a full copy of the blockchain. They're able to serve that full copy to peers and basically ensure that the Bitcoin blockchain continues to be accessible for anybody that wants a copy, which is really important, because if we lost that historical data, then that would destroy the integrity of the ledger and make it much less likely that people are going to trust that history or even the current UTXO set. So by storing a full copy, you're able to validate all the way back to the Genesis block that the current UTXO set is valid. And UTXO just means like unspent transaction outputs. So basically the current kind of state of everyone's balances on the ledger. And finally, as I mentioned, perhaps the most important type of full node is the economic full node. And economic full nodes are full nodes that accept Bitcoin in exchange for value. So instead of just sitting there on the network, kind of passing messages back and forth, they are actually, people who use economic full nodes are actually using their full nodes to verify incoming transactions. And then based on the validity of those transactions, actually exchanging Bitcoin for goods and services of real value. So these are the nodes that actually give Bitcoin monetary value and determine through consensus what is Bitcoin. Like last year, during the Bitcoin Unlimited thing, and then like SegWit 2x, there was a lot of questions of, if a hard fork happens and there's a chain split, which version of the blockchain is like the canonical quote unquote Bitcoin. And it's really economic full nodes that determine what is Bitcoin by putting their economic weight behind one chain or the other. And of course, miners will then follow the economic majority so that they can make the most amount of money mining. And so without full nodes that are willing to accept Bitcoin in exchange for valuable goods and services, Bitcoin would basically be worthless. And you can read more about this on the economic majority page of the Bitcoin wiki. This is a screenshot from a program that Bitcoin Core developer Luke Jr. is running. I put a link to it in the source at the bottom of the slide here. But this shows that kind of based on his last scan of the network, there were approximately 79,973 archive nodes, meaning full nodes that are storing a full copy of the blockchain, and 9% of those, or about 7,700 of those archive nodes, were listening nodes. So 86 or 87% were non-listening or selfish nodes that were just downloading block data, and 9% were actually listening nodes that upload data back to the network. I think this is an important chart because there are a lot of people that will go to like bitnodes.com, which is like this map. You'll see something like this pretty often, and they'll say, well, hey, it says only 9,000 nodes, or on this chart like 7,700 nodes. That's not a lot of full nodes, but those are only listening nodes, and that is an important metric. But it does ignore the tens of thousands more non-listening nodes that are still participating in full validation of the blockchain. And those could be merchants, those could be traders, those could be average users. We don't know what these people are using their nodes for, but the fact that they're participating in full validation and decentralized consensus is significant. And so there's about 80,000 of those nodes that Luke Jr.'s crawler has been able to detect. There could be more. There could be even more. It's hard to make an exact measurement just due to the decentralized nature of the network. So again, this is kind of a bitnodes map. You can generate your own map that looks like this at bitnodes.earn.com. And this just kind of shows you geographically where all of the full nodes that are listening on the network are located. I should note that I do not believe that this map takes into account listening nodes that are running over Tor. I believe this map is only mapping the ClearNet listening node network. So if there are listening nodes running over Tor that are serving Tor peers with block data, I'm pretty sure that they're not showing up on this map. So what are the benefits of running a full node? Some of these you could say are objective, others are my own subjective benefits that I would personally say are benefits of running a full node. But one of the benefits here is trustless validation of interesting transactions. Full nodes protect the privacy of balanced lookups. They decentralize validation and block and transaction relaying. And archival nodes in particular preserve the full blockchain and can make it available to new peers on the network. And we'll dive into each of these individually here. So trustless validation of interesting transactions. What does that mean? It means that no trusted third parties are required for transaction validation. And so here, basically, if you're using a wallet like, say, Mycelium or blockchain.info, those companies are basically running a full node on your behalf, and you're just asking those nodes like, hey, these are my addresses, what are my balances? And when those nodes send you a response back with your wallet balances, you are trusting explicitly that those full nodes have actually properly validated those balances, and the blocks that those balances were included in, and you're not doing your own validation. You're outsourcing that validation to a trusted third party. So with your own full node, you can validate for yourself that a transaction was included in a block that was added to the most difficult valid blockchain. So your full node is checking the proof of work on all of the blocks, and it's also checking the validity of all of the transactions and other data that's included in the block as well. There have been problems in the past where miners weren't doing full validation, and they were only doing SPV validation or SPY mining, and they actually mined on top of invalid blocks, which caused a reorg, and caused not only the miners to lose money, but anybody who had their transactions included in one of these blocks that got orphaned, that transaction was basically reversed, because a valid version of the blockchain like overtook that version of history. So anybody that wasn't doing full validation and was just trusting, basically trusting miners or trusting just the block headers, they had their transactions reversed, and maybe their transactions were included in one of the valid blocks on the valid blockchain, or maybe they had to submit their transaction to another block. But so full validation basically ensures that you don't have to trust miners to validate the blocks. You can actually validate all of the blocks for yourself. Full nodes also protect the privacy of balanced lookups. So in addition to not having to trust a third party with block validation, you also don't have to trust a third party with the privacy of your wallet balances. So you can look up wallet balances without linking your addresses together. Like I said, if you're using a wallet that has a centralized node that's run by a trusted third party, your wallet is basically sending all of its addresses to that third party and saying, hey, here's the addresses I'm interested in. Please send me my balances back. This is really convenient because you don't have to run your own full node, but it's also really bad for privacy because now that central third party knows all of the addresses that you're interested in and can basically link all of those addresses together and say, all of these addresses are owned by the same person. And this can be bad for privacy. For example, if one of those addresses was used to donate to WikiLeaks or something, and another one of the addresses was used to receive your monthly paycheck, then it's really obvious to that third party that those two addresses are the same people. So the same person that's getting paid by, whatever your employer is also the same person that's donating to WikiLeaks. Unfortunately in society today, that can be problematic for someone's career or even potentially at from a legal standpoint. So trusting third parties with the privacy of your addresses is not ideal. Additionally, you can look up other address balances without letting a third party know what addresses you're interested in. This is a little bit different. Here I'm referring not just to your own wallet addresses, but I'm also referring to any address that you might be interested in checking the balance of. So maybe, for example, you sent a payment to somebody and you wanted to see if the payment it got confirmed on their end, or you want to see, for example, how much Bitcoin a particular address has received in donations. Then you could look up that address balance without like letting a third party know that you specifically are interested in that address. Again, with the WikiLeaks example, if you want to see how much Bitcoin WikiLeaks has received in donations, you can just query your own private full node for the balance of WikiLeaks's Bitcoin address, and then get that balance back. And no third parties will ever need to know that you specifically were interested in WikiLeaks addresses. Again, WikiLeaks is just an example. It could be any third-party address that you're interested in. Perhaps more politically or legally sensitive or less so. It doesn't matter. Taking a sip of water here. So next, full nodes, decentralized validation, and block and transaction relaying. That's a lot of big words. Let's break it down. At a basic level, this is a way for you as a full node user to hold miners accountable and keep them honest. As I mentioned earlier, there have actually been instances where miners built on top of invalid blocks. Really, anything could have been happening in those blocks. New Bitcoin could have been created out of thin air. The blocks could have been much bigger than the actual block size limit. They could have been double spending Bitcoins. Really, they could have done all kinds of different bad things in these invalid blocks. But because there was a giant network of fully validating full nodes, keeping them honest, all of those invalid blocks ended up getting orphaned, and the miners lost the block rewards that they earned from all of the blocks that they built on top of the invalid blocks. So it's important to have this large decentralized network of fully validating nodes in order to hold the miners accountable and keep them honest. And also, by having this large network of listening nodes, you can actually prevent censorship by routing the blocks created by miners and transactions created by users. So you can imagine on the extreme scale, if all of the blocks and all of the transactions had to go through one node, or just a very small handful of nodes run by like a cartel, that one node or that cartel of nodes could very easily censor blocks that were created by, say, miners that weren't their friends, or by or censor transactions that are being sent by users that the one master node or cartel nodes don't like, or censor transactions that are being sent to a user that the master node or cartel of nodes doesn't like. So because there's this large decentralized network of many thousands of listening nodes, the odds of that kind of censorship actually happening are significantly reduced down to practically zero. As long as you're paying a market rate fee for your transaction, it's probably going to get into a block. And as long as you're producing valid blocks and you're like the first miner to produce that valid block, and you can get that block to a majority of the network quickly, your block is going to get added to the blockchain. And that's because the network has this large decentralized group of fully validating listening nodes. And finally, perhaps the most important role of archival full nodes in particular is preserving the blockchain history, which, of course, it makes the full blockchain history available to new peers. That's like the day job of an archival listening full node. And then its kind of backup purpose is to keep Bitcoin going after a catastrophic failure. So, let's say something crazy like a black hole in the center of the galaxy shoots a pulsar or something like that. I'm not an astrophysicist. It shoots some like crazy radio waves at Earth and like knocks out all of our electricity. That would suck. But it is something that the Bitcoin network could recover from, because there are like thousands of computers that are storing a full copy of the Bitcoin blockchain. And you could basically, once you get like electricity and the internet and stuff working again, you could recover by just bringing online one of these archival full nodes that has like the most recent copy of the blockchain. Maybe you lose some data like in the last couple of days because a backup wasn't taken or something like that. But you don't lose everything, which is really great, and will be especially useful after more than a decade, many decades of blockchain history. Like if you lose a few years, it's like, oh well, that was an interesting experiment. Like it sucks that it failed like that. But if you have like decades of history that are being preserved by the blockchain, it's really important that you're able to like recover from a catastrophic failure like that, or else civilization basically melts down. That is, assuming that after decades of its existence, Bitcoin is used for significant civilizational infrastructure, which I believe it is, and will be. So I'm going to take a pause right now and start taking some questions from the audience before kind of moving on to talk more about kind of Bitseed and what we do as it relates to full nodes. So Michael, if you want to either take questions or send people up to ask questions, I'll be happy to answer.
How big is the...
okay, cool. Do you want to come up to the computer? Okay, say again.
How big is the full blockchain history now, and at what point, what's the rate of growth?
How big is the full blockchain history now, John, and what's the rate of growth?
Well, what I can do is I can just show you exactly. So we'll just go to blockchain.info. This is a pretty like common block explorer. They have some cool charts that show you these kinds of statistics. So this is the blockchain size. It grows more or less linearly because there's a cap on the block size limit, and so the blockchain is only going to grow linearly, kind of at most at the size of the max block size. So right now it says the block size, or excuse me, the blockchain is about 176 gigabytes in size, and it grows at somewhere between 1 megabyte and 2 megabytes every 10 minutes. So that's like, between 6 and 12 megabytes an hour, which is, I'm bad at math, but it's about 150 megabytes per day or something like that. So yeah, I would say it's probably somewhere around like, I want to say around 50 gigabytes per year at this point, but could be off on that. But it's not like a crazy growth rate. Last year with the implementation of SegWit, the max block size basically changed from 1 megabyte to 4 million weight units. They changed the way that they measure blockchain data sizes, which comes out to be about like 2 to 2.5 megabyte sized blocks. Yeah, so that's kind of as big as a block can get. And yeah, I hope that answers your question.
Cool, thanks, John. Another question, does the fact that you showed the chart with 87% of nodes being non-listening, does that pose a challenge if there is a lot of growth in non-listening nodes in comparison to a small proportion of listening nodes in terms of getting those nodes to sync up and stay up to date with the latest state of the blockchain?
Yes. So each listening node can support like around 100 to 150 like slots, you could say, that non-listening nodes can kind of plug into. Non-listening nodes and SPV nodes can plug into to download data from. I don't know if that's like a fundamental limitation or just a limitation imposed by Bitcoin Core. I imagine you could invent full node software that allows more nodes to get plugged in, but that's how Bitcoin Core works by default today. So, you know, if more than 120, 130 full nodes, non-listening nodes are plugging into a listening node, or trying to plug into a listening node, you're going to start having some syncing problems for sure. So the number of non-listening nodes is kind of capped for being online at any one time by the number of listening nodes that are online at any given time.
Cool, thanks. And a quick follow-up, like Vladimir, one of the core devs, was talking on Twitter about problems with the universal plug-and-play library, and hence perhaps it's not a good idea for people with not much technical expertise to be set up as a listening node. Do you have any view on that from Bitseed's perspective? And like, what advice do you provide your users and customers?
So that's referring to Vladimir Vanderland. He's the kind of he's the maintainer of Bitcoin Core. Super smart guy. I respect his opinion a lot about this. We did turn off UPnP for a period of time back when the kind of vulnerabilities in UPnP were first disclosed. We believe that UPnP is basically fine for what it's used for right now. So we do have it enabled. Basically, UPnP, that's short for the Universal Plug and Play Protocol. What this does is, if your router supports the UPnP protocol, once you like plug in your Bitseed node and put it on your local network, it will like talk to your router and automatically forward the ports necessary so that Bitcoin becomes a listening full node. And so if you still, for whatever reason, feel uncomfortable with using UPnP, you can disable it and you can just manually forward those ports. It takes a bit of extra work because you have to like log into your router, figure out which IP address your Bitseed is sitting on, forward the ports properly, etc. But it's totally possible and totally doable. We don't provide instructions for this because every router is different. But if you don't feel comfortable using UPnP for any reason, you are free to disable it and forward your ports manually. Another thing that we do is we have Tor running on Bitseed by default. So if for whatever reason UPnP doesn't work, you've disabled it, your router doesn't support it, your node is still going to be listening on the Tor network and supporting other peers that are connecting to you through Tor. So we have a few different options for people who don't want to use UPnP for any reason. But I think it's fine for what it's used for today, especially since we don't store any secrets on Bitseed. So even if there was like some sort of like remote code execution vulnerability or anything like that, the damage that could be done by a hacker is extremely limited. So we feel like the convenience trade-off is worth it at this point.
Great, thank you. Another question?
So when we go to the bitcoin.org and we download the Bitcoin core and we fully sync and first I went to the website, I downloaded the Bitcoin core and then I opened the port in my router. Does that make me like a target? Am I secure to continue using Bitcoin like new transactions in that node, or because I'm running it locally, I'm a bit insecure, like by opening ports and what type of when he was talking about the type of Bitcoin nodes, what type is the Bitcoin core by default? Is it a full?
So first question, John, what's the Bitcoin core node? You talked about the different types of nodes. What's a Bitcoin core node by default?
That's a great question. So if you have Tor running on your computer at the same time as you're running Bitcoin Core, then by default, Bitcoin Core is an archival listening node running over Tor. So it's storing a full copy of the Bitcoin blockchain, it's doing full validation, and it's uploading data back to peers over the Tor network. If you're not running Tor, then by default, Bitcoin Core is an archival selfish node. So it's only downloading transaction data and block data. It's not uploading anything back to the network because Bitcoin Core, I believe, still to this day has UPnP disabled by default. So even if your router supports UPnP, because Bitcoin Core has it disabled by default, your node defaults to just downloading block data and not uploading any data back to the network.
Okay, thanks. And the second part of that question was, what other security considerations are there when opening and manually forwarding ports? Should a non-technical user educate themselves about the security implications of doing that?
I would say from a layman's perspective, there's not a significant security implication. I mean, if there's a vulnerability in Bitcoin Core that can be exploited using malformed transactions or something like that, then there's a potential that opening your ports could cause some problems. But assuming that Bitcoin Core is working properly as expected, there aren't any like special security considerations for opening the ports. That said, I always encourage people to not store their life savings on their computers and only keep like pocket change in any hot wallets whether you're running a full node with ports open or not. Yeah, I would say, just running a full node with ports open, you're not really exposing yourself to any significant kinds of vulnerabilities that you wouldn't already be exposing yourself to just by connecting to the internet in general. And if any security experts are watching this and want to correct me on that point, I welcome any new info on that topic.
Okay, cool. Thanks, John. There's some more questions, but we'll ask them at the end. So do you want to continue your presentation?
Sure.
Is that good? Okay.
So I said live demo here, but then I realized that if I do a live demo, I'm going to expose my public IP address, and I don't really want to do that. So I'm just going to show you what our UI looks like. And so this is the UI. This is like the main status page. We show you, this is an old picture, that's why it says 0.12. But the UI is essentially still the same. So this is a status page. It kind of shows you what version of Bitcoin Core you're running, what kind of full node you're running, what is the device block height, how many peers are connected to you. Basically, if it's more than 8, it means that your node is listening. If it's 8 or less, it means that you're just a selfish node. Because by default, your node will just like connect to 8 peers at most. But once you kind of switch your node into listening mode, either automatically or manually, your node will start to connect to a lot more peers, so it can start serving block and transaction data to those peers. It tells you how many transactions are in your mempool. This is really interesting to watch, like during periods of high Bitcoin usage in particular. You could start to see 5,000, 10,000 or more transactions in your mempool. It shows you your minimum relay fee, which means that your node will not relay any transactions that have a fee of less than this amount. It'll show you your internal IP address, which if you're looking at this status page, you already know. And then, for troubleshooting purposes, it'll show you your device ID and your version as well. So if you have a problem, you can let us know this information, and we'll kind of try to help figure it out. We also have a settings page, and this is the mobile view of the settings page. It basically looks the same on the desktop, but that's the mobile view. So we have a few checkboxes that we created that should make it like really easy for non-technical users to set the settings that are perhaps most important to running a full node. For example, we have a button that says auto update. I think we actually disable that by default now. But we used to have an option where users could basically run a script that automatically checks for software updates from Bitseed like once a week or something like that. We have a Tor enable button, which it's pretty self-explanatory. You're either running Tor in the background on your full node or you're not. We also have a Tor only mode. So if you have Tor enabled checked, but you do not have Tor only checked, then that means that your node is running as a hybrid Tor ClearNet full node, where it's both connecting to nodes on the ClearNet side of the Bitcoin network and is connecting to nodes on the Tor side of the Bitcoin network, and essentially serving as a bridge, passing messages back and forth between the ClearNet and the Tor network. As I mentioned earlier, this is really important because these are the kinds of nodes that help keep Tor nodes or nodes that are connected on the Tor side of the network, it keeps them in sync with the rest of the network that's running on over ClearNet. So if you can run a hybrid node, you're willing to run a hybrid node, those are super valuable for all of the nodes on both the ClearNet and the Tor side of the network. But if you only want to connect over Tor, that's okay too. You can just click that Tor only box, and then your node will only be connecting to other nodes over Tor. We also have a button to enable or disable UPnP. We just talked about that a little bit earlier. And then this is another setting that I believe we have disabled now, which is a blockchain backup. Basically, on older versions of Bitseed, we were using a relatively low power ARM board. It was basically a Raspberry Pi clone called PCduino Nano 3. And it would just take forever to validate the blockchain. Like, I would be surprised if it could start from scratch and then catch up to the chain tip and stay caught up nowadays, just because the CPU power was so weak. But what we would do is we would sync the blockchain on another computer and then import it into the devices and then ship the devices. And we would keep a backup of the blockchain so that if for any reason the current active version of the blockchain that the node is using was corrupted, it could import the backup copy without having to re-download and re-verify, the entire blockchain, which would again take forever, if not, like never get caught up to the chain tip. So Bitseed now uses a mini PC with an x86 board. It's much faster. It has much more RAM, much more CPU power. So I don't even think we store a backup, a blockchain backup anymore, because the new Bitseed 3 model is able to download and catch up to the chain tip relatively quickly, pretty much as fast as a normal desktop or laptop computer would be able to. So that's an old setting, but it is an option that's available for people that are still running old versions of Bitseed. And then we have the minimum relay transaction fee. I explained this earlier. Basically, your node won't relay any transactions that have a fee that's less than this amount. This is useful for like preventing spam. So if someone is spamming the network with a bunch of like 1 Satoshi fee transactions, then you can basically just, with this setting, you can tell your node to just ignore all of those transactions. And those transactions won't even get, relayed. There's a daily upload limit. As I mentioned earlier, some people have like bandwidth caps, and so it's nice to be able to set an upload limit. I mean, this is useful even if you're running your node in the cloud, because maybe you're getting charged for data, like bandwidth usage by your hosting provider, and so you want to just set an upload limit so you don't end up with like $100,000 AWS bill or something like that. And then there's a mempool size limit option as well. And this just basically helps you limit the amount of mempool data that you're storing. I believe it's stored in RAM. And then once you've like messed with your settings, you would just click the update settings button and then restart Bitcoin so that your new settings take effect. And finally, we have like a device status page, which will tell you like how big your disk size is, how much of that space is used, how much of that space is available, how much RAM is used, how much RAM is free, your CPU load, uptime, the uptime of your node, the MAC address, and the last backup time. And again, like Bitseed 3 does not do blockchain backups anymore, so you probably wouldn't see this this specific statistic if you're running Bitseed 3. But for older models of Bitseed, we would let people know when the last time their node did a backup, which was approximately once per week. And I'm excited to say that we actually have a community member that is working on a new open source web interface for Bitseed. Let's see if I can get our Twitter page to show up. And I will show you kind of a sneak peek of what that new user interface looks like. So this is kind of an early version of the new interface. It looks, pretty similar. But I think one cool thing to point out is that this one has an Electrum tab. So one of the projects that this community member is working on is making it easy for Bitseed users to also run an Electrum personal server on their full nodes so that they can connect their Electrum wallet to their own full node. And then, with that feature turned on, a Bitseed user would be able to connect their Electrum mobile or desktop wallet to their own private full node and not have to share any of their transaction data with third parties, and still be able to do full validation, do private address lookups, private wallet lookups, private transaction broadcasting. This is really cool. And of course, if you're like the cool guy in your friend group, and you're the one that's running the full node, then you can also share your Electrum server with your friends, and they can use your full node as well. But I think that's going to be a really cool feature that's gonna bring a lot of value to Bitseed users. And of course, because this web interface is open source, anybody that's running a compatible full node will be able to use this interface as well. So that's kind of that's all I've got in terms of content. Happy to turn it back over for questions if there are any more questions either about Bitseed or full nodes in general.
Okay, cool. Thanks, John. So first question. What's your selling pitch for why someone should buy a Bitseed? You talked about why people should run full nodes. Why should someone buy Bitseed?
Yeah, so Bitseed is designed for people like me, essentially. I really started working on Bitseed to scratch my own itch, which is, I want to be able to run a full node without having to run it on my desktop and take up a bunch of space on my personal hard drive, and take up a bunch of computing resources and bandwidth, et cetera, on my own personal computer. But I also don't want to run it in the cloud, because I'm not a systems administrator. I don't really feel like dealing with setting up servers and paying monthly hosting fees and figuring out how to do SSH into the command line on the server and keep it up to date and blah, 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 blah. There's a lot of effort that goes into maintaining a full node in the cloud, it feels like. And plus, like, then you're just like, your server is running on, or your full node is running on somebody else's computer instead of your own computer. And so if you're actually using your full node for like full validation or any other kinds of like sensitive tasks, that full node could end up being compromised by either your host or, if you're using a VPS, maybe one of your neighbors on the VPS. There's a lot of shenanigans that can happen when you're running software on someone else's computer. And so Bitseed is designed to be a full node that runs on a separate machine. So it's not running on your personal PC or laptop. It's running on its own dedicated machine. inside your personal firewall, either in your home or at your office. So it's running on dedicated hardware that you are in full control of. And this kind of puts Bitseed in what I call the Fourth Amendment zone. I don't know if there's an equivalent in the UK, but basically it means that your Bitseed is safe from third party like hosts that might want to mess around with your full node. Maybe, like I said, VPS neighbors if they start to sniff around on the server, or warrantless searches if it really comes to that. So Bitseed, in short, is a way to easily run your own full node on hardware that you control inside your own network without having to use up any resources on your main work or personal computer.
Great.
And you get all of the benefits of a full node, plus all of the benefits of running a node on your own personal computer.
That's good.
We see more often these days, for example, on Twitter, these full nodes being loaded on Raspberry Pis, and they even include now the Lightning Network. And how performant are those full nodes on Raspberry Pis? Is it something that actually is good for the network, or is it mostly just for testing and showcase?
How performant are the full nodes that are running on Raspberry Pis and similar devices? Are they assisting the network just like all other nodes, or are they just for testing and developers experimenting?
They serve both purposes, really. I mean, they're fully validating blockchain data. If they're listening on the network, they are serving that data to other peers. As long as they can keep up with the chain tip, they are useful to the network. So I believe that Satoshi Place, the $1 million homepage for Bitcoin or whatever, that people were playing around with on Lightning, and I'm sure still play around with to this day. I'm pretty sure that website was actually run on a full node that was on a Raspberry Pi. So dozens or maybe hundreds of people were connecting to that node over Lightning and drawing penises and Bitcoin Core logos and other silly stuff on the homepage of the website. So yeah, you'd be surprised what Raspberry Pis can actually do nowadays.
But at some point, with that graph you showed earlier with the size of the blockchain increasing linearly, at some point you're not going to be able to run them on Raspberry Pis, right? Unless Raspberry Pis increase at a similar rate.
Well, Raspberry Pis, so that's more to do with the hard drive size. Mm-hmm. And Raspberry Pis can plug into any size hard drive. I've never seen a Raspberry Pi with a RAID setup, but I imagine that's probably possible. But even today, you could plug a 2 terabyte hard drive into a Raspberry Pi, and it'll work. Where Raspberry Pi starts to slow down is if the block size itself gets too big. So a Raspberry Pi has a certain amount of processing power, and both in terms of RAM as well as CPU. And the bigger the block size gets, the more processing power you need to validate each block. And so after a certain size, and I'm not sure exactly what size that is, but based on my experience with Raspberry Pis, I would imagine it's not much bigger than 2 megabytes. Anyways, after a certain size, a Raspberry Pi is not going to be able to keep up with the chain tip. Essentially, it's going to take longer to validate a block than it takes for miners to produce a block. And so that means that the node will start falling behind and it will never be able to catch up because it's always going to be still validating the previous blocks as new blocks are coming in. And so it's like never able to catch up to the chain tip. And this is one of the reasons why so many people are so hesitant to raise the block size limit beyond a certain point. It's not just that, hard forks are hard. Like, I think pretty much every core developer, every Bitcoin developer that's realistic with themselves knows and accepts and has said that Bitcoin is going to have to hard fork eventually to clean up some, some existing bugs, as well as potentially increase the block size beyond 1 megabyte. So like, that's not the only reason. Really, it's like, what should that block size be, if they decide to increase it by way of a hard fork, or even if it's a soft fork through like extension blocks or something like that. You have to be careful about once you start basically excluding nodes from validation, because this reduces decentralization of the network and removes some of those benefits that I talked about earlier, that decentralization of validation kind of brings to the table. It reduces the number of nodes that are kind of keeping miners honest and in check. And it also reduces to a degree the censorship resistance, the overall censorship resistant properties of the network. And so many people are very hesitant to start making changes that will be excluding certain kinds of nodes from participating in full validation.
Okay, thanks. Yeah.
It's just a bit trying to understand the difference between a full node and what do the miners run on their side?
What do the miners run in terms of full nodes on their side? They're running multiple nodes, right? And the type of node that the miners are running.
If a miner is being responsible, they are running their own full node. It's probably just an archival selfish node in order to preserve bandwidth. But like, mining pools at the very least are serving blockchain data to the miners that are connected to those pools, so that the miners know, like, what they're mining on and stuff like that. But yeah, every miner is connected to a full node in one way or another, because they need to use that full node to ensure that the block that they're building is valid, and that they're building on top of a valid, the like current most difficult valid version of the blockchain. There's nothing like, there are maybe like a few minor tweaks that they've made to their full nodes to make it like optimal for mining purposes, but other than that, it's just like an off-the-shelf piece of software with maybe some small modifications. And then cool. and then they're running like mining software like next to the full node, which is separate. Like, there's, I don't know, probably a dozen at least different kinds of mining software that miners could use, including like proprietary versions of software if they develop their own mining software. And that mining software will just like, it'll talk to the full node, but it'll also talk to the miner's mining hardware and, take new transactions, hash them into a block, iterate on a nonce until it finds a header that matches the proof of work, and then it'll broadcast that block back out to the network.
So another question, what do you think the roadblocks are to more people running a full node? And do you think the excitement around Lightning will incentivize more people to run a Bitcoin full node?
Some roadblocks. Part of it is incentives. I think another part of it is just ease of use. And so at Bitseed, we're trying to tackle the ease of use part. And part of that means not just ease of use in terms of like running the full node, but also ease of use in terms of making that full node useful to the end user. We have a lot of people who buy Bitseeds, and they're just happy to connect it to the network and to support the network. But I think a lot of people are hungry to use their full node for more direct personal use in terms of actually using their full node to verify their own transactions, and maybe even like set up a Lightning node and provide liquidity to the Lightning network. And so we are tackling both of those common requests kind of in parallel. On the one hand, as I mentioned, we have a community member that's working on adding Electrum support to Bitseed. So you'll be able to connect your Electrum wallet, desktop or mobile wallet to your Bitseed node. And I think that's going to be a huge win because not only is Electrum just a really great wallet by itself, Electrum also supports connecting to a hardware wallet. And so once you have Electrum running on your own full node and your desktop or mobile wallet connected directly to your own personal Electrum server, you can then use your hardware wallet with your own full node. Today, the hardware wallet software does not make it easy. I don't even think it's really an option for you to connect to your own full node just using the default interface for these hardware wallets. But Electrum provides an interface that allows you to connect your hardware wallet to Electrum. And so if you're connecting your hardware wallet to Electrum and then Electrum to your own full node, then you can actually use your hardware wallet with your own full node, meaning that you're not sending your wallet balances to Trezor or Ledger's servers, which I think is a huge win for privacy and security. So we're really excited to get that out. We're going to be working with Marco, who's the community member that's working on this feature to test this, and we'll probably have something usable by the end of summer. And then on the incentives and the Lightning side, the next thing that we're going to start working on after this Electrum feature gets pushed out is Lightning integration. This we're going to be moving a little bit slower on because I'm personally very skeptical of the idea of keeping private keys on in a hot wallet online all the time, especially if it's like connecting to other nodes and sending money around kind of unattended. But I understand that people are excited about this, and if they're just putting a couple $100 on the node, then there's not a lot to lose. And so we're going to look at how we can make it super easy for people to set up their own Lightning node and not just use that node for sending and receiving money on the Lightning network for their own purposes, but also using that node to help route other people's payments as well and provide liquidity to the network, maybe earn some Satoshis providing that service as well. And in that way, people might actually have a direct financial incentive to run their own full node, so that they can participate in providing liquidity to the Lightning Network and earning some routing fees in exchange.
Cool, thanks. Just a couple more questions, and then we'll let you go, John. Can you switch to your face? I think we've got, just for the last couple of questions, I think we've just got the Bitseed page up. Cool. So just a couple of fun questions. One, can you talk about the challenges of building a hardware startup, and how Bitseed has evolved since you started it, what was it, 2-3 years ago?
Yeah, I don't know if I would characterize Bitseed as a startup, really. I think of it as an open source project that happens to have a monetization, a relatively easy monetization mechanism built in, which is, we sell hardware that's used to kind of power our software. And really, it's at this stage of its development, I would say it is and has been kind of a side project, in the sense that I don't think that Bitseed revenue at this stage could be enough to like sustain, say, salaries for the people who are working on the project. But maybe that could change in the future if we, make Bitseed useful for people, and just generally get more people excited about running their own nodes. But I think it would something would significantly have to change either in the market or in the software or some combination of these things to make it into like an actual business. But today, Bitseed hardware sales, they sustain themselves, meaning that we can continue to like order new parts and ship new orders. And then we have like enough left over to pay for hosting and some software development, but not much more than that. And so in short, I'm not sure that I actually know what the challenges are with running a hardware startup, because I don't consider Bitseed to be a hardware startup. But if we start selling more nodes than we can like build by hand, which is what we're doing today, then we might start to actually experience some of those challenges, like supply chain stuff, dealing with vendors, and security and other challenges like that once you start to have to kind of outsource a bunch of stuff. But we're not quite there yet.
Cool. A couple of process questions. So how easy is it if me and a few friends buy Bitseeds for us to be able to discover each other's nodes and interoperate between our nodes? And also, how easy is it to connect remotely to a Bitseed that I leave at home?
Well, to the first question, I'm not sure what you mean by interoperate between the nodes. What exactly do you have in mind?
So when you discover nodes on the network, and you want to perhaps you want to connect nodes on the network, rather than just the default ones that you connect to using Bitcoin Core.
Yeah, I see what you mean. So what you would have to do is you would get you and your friends' public IP addresses on port 8333. You would have to like SSH into your nodes and modify your configuration file to connect to those IP addresses, so that your node is kind of connecting to those other nodes by default before trying to connect to any other peers. It's relatively easy to do. But it does mean that you have to go into the command line. And today, we don't support modifying the configuration file from the UI. You have to do that from the command line. That could change in the future. But today, that's kind of like what you would have to do. So by default, the kind of the default mode of operating Bitseed that we have in mind is that users never have to touch the command line interface. But if you do want to like do something kind of complicated, like modifying your configuration file, you are going to have to use the command line interface, which isn't as scary as it sounds, but there is a little bit of a learning curve if you've never touched the terminal before. So that's the interoperability question. The second question you asked was about remote nodes. Basically, don't do it. You either can't do it or you shouldn't do it. And the reason is that, first off, Bitseed does not let you SSH into the node unless you are unless you're on the local network. Second, we do have a public status page that you can visit just by going to the external IP address or public IP address of the node on port, I believe it's port 80. And so that is possible. And by just visiting this status page, I showed you what the status page looks like. It shows you like what block height you're at and like how big the mempool is and things like that. So you can kind of monitor your Bitseed remotely and make sure that it's online and that it's keeping up with the current block height. But you can't actually mess around with the settings for security purposes. You can only do that when you're inside the same network as your Bitseed. And then in terms of like connecting your wallet to Bitseed, we won't be able to support that until we support Electrum, because today, if you want to do that just using Bitcoin Core, it's just not secure. Bitcoin Core does not support HTTPS, authenticated or encrypted connections. And so, if you're going to connect, for example, your Shieldbach Android Bitcoin wallet to your own node, like the Shieldbach wallet has an option where you can connect to like a trusted node by just like putting in the public IP address of the node. But that connection between the wallet and the node is unauthenticated and unencrypted, and so it could be easily man-in-the-middled. And of course, all of the data that's being passed between the wallet and the node can be sniffed on the wire by anyone that's like watching the network. So all of those requests are public and they can be man-in-the-middled. Not good for privacy, not good for security. So we really don't recommend that people do that. But once Bitseed supports Electrum Personal Server, you'll be able to connect to that server through a authenticated and encrypted connection, either using like SSL or end-to-end encryption through the Tor network.
Would the Bitseed need a static IP address for that to work?
For the Electrum server to work? If you're using HTTPS, yes. If you're using Tor, no, because Tor does not use IP addresses to route messages.
Okay, cool.
Yeah.
Well, thank you very much, John. That was really, really interesting. So we'll thank our and also thank our sponsor Monzo for hosting the meetup. Thank you very much for your time, John. That's really interesting.
Yeah, thanks a lot for having me. Really great questions.
Cheers, John. See ya.